Hello, welcome back. Today I'm going to be going through some maths such as topics, keywords, definitions, examples, so it can help you understand the question when you're doing one and understand the work. So I hope you understand a lot, and if you need any other help or any questions to ask, please just write them down in the comments and I will help you out. Thank you. Let's start. So, our first topic is going to be basic number and decimals. So this is a very quite easy, simple topic, but as we go, it will get harder and harder. So we've got topic, definitions, and examples. I'm going to be going through them, and if you need any help, let me know in the comments. So our first topic or skill is going to be integer, okay? So the definition of integer is a whole number. So it can be a positive or a negative or a zero. So if any time a question comes up with the word integer, just know that it means a whole number. So in other words, it just means like a whole number, okay? It usually mostly comes up for fractions. So if this is an integer, so for example, 2 wholes, that is an integer because it's the whole number. 2 wholes and 1/3. The 1/3 is a fraction, and the integer is a 2, okay? So for example, -3, 0, or 92, they are all integers because -3 is an integer even though it is a negative, 0 is an integer because zeros are integers, and 92 is also an integer. Perfect. Let's move on. Okay, our next one is a decimal. So decimal is a number with a decimal point in it. It can be a positive or a negative, okay? So do not get confused when we say decimals because it just means a number with a point in it, okay? But it can't be a 0, okay? It has to have that point, okay? So it can be a positive or a negative number again, okay? So it can be, for example, 3.7, 0.94, and negative 24.07, okay? It's really simple. Okay, now negative number, okay? So negative number is a number that is less than 0. It can also be decimals. So for example, it can be a negative 8 or negative 2.5. So just remember, the further you get from 0, the smaller the value of the number is. So negative 5 is less than negative 0. Okay, it is less. Negative 0 has a greater value than negative 5. So the more the number is further away from the 0, the more smaller the actual value is, okay? Okay, now addition. To find the total or sum of 2 or more numbers. So in other words, you can call addition add, plus, or sum, okay? It's when you're finding the total amount. So you're making it come together, and it always makes it bigger. Okay, so for example, 3 add 2 add 7 equals 12. Again, the value is getting greater. 5. Subtraction. So, in other words, to find the difference between 2 numbers. So it's to find out how many are left when some are taken away. For example, in other words, you can say minus, take away, subtract, okay? So, if you ever find the word the difference, find the difference, just know it means subtraction, take away, okay? So it's very simple. It's when you take away stuff and you have to count how many are left over, okay? So for example, 10 take away 3 equals 7. Very simple again. Now 6, multiplication. So this can be thought of as repeated addition, when you repeat addition, okay? So in other words, multiply times a product. Product is another word you can say to multiply. It might be a bit more up level and you might not have come across it, but if you are probably in secondary school, you might have come across it. You should have come across it, okay? So we've got 3 times 6, which also equals 6 add 6 add 6, which equals 18, okay? 6 add 6 add 6 is an example of repeated addition, and that is also an example of multiplication, okay? So if you didn't know what repeated addition was, that's what it is. Perfect. Division. Okay, division can be a tricky one sometimes, but once you get into the hang of it, it's not that tricky actually. So it means splitting into equal parts or groups. So it's the process of calculating the number of times one number is contained within another one. So it's when you divide or share. When you have groups, you decide to share them. So imagine I had 6 sweets and I had 3 people. I was going to share them equally. I would give them 2 each. 2 each. But if I had 7, I would have 1 left over, okay? So that would be my remainder. And we are going to come across it in the next one, what a remainder actually is. Okay, so for example, if I had 20 divided by 4 equals 5. okay? So if you didn't know already, 20 divided by 4 is the same as 20 over 4. That line over there means a division symbol, okay? If you didn't know this, a fun fact. 20 over 4 also equals 5. So this way, the fraction way, is the way we normally use inside our GCSEs. In other tests, I would use that. And it's more mathematical, okay? So more mathematical way. That's what we would use, okay? So let's move to the next one. Now, remainder. As we were talking about it, for our division, we have remainders. Now we'll talk about what it actually is. So the remainder is the amount that's left over after dividing one integer by another, okay? So again, integer meaning whole number, okay? So once you divide one integer by another, you will get a remainder. Or if it's perfectly divided into, if it's equal, then you won't. But if it's not equal, such as I said, 7 divided by 3, 7 divided by 2, you will not get a fair amount. So you will always have a remainder for those, okay? So the remainder of 20 divided by 6 is 2, because 6 divides into 20 exactly 3 times with 2 left over. Do we see how it works? Okay, because 6 times 3 equals 18, you have 2 left to get to 20. 2 left over. Perfect. Simple. Okay, now BIDMAS or BODMAS, okay? So it's an acronym for the order you should do calculations in. So BIDMAS stands for brackets, indices, division, multiplication, addition, and subtraction. So we've already talked about multiplication, addition, division, and subtraction. We haven't yet talked about brackets or indices, okay? Okay, so indices are also known as powers or orders. So if you ever heard anyone say to the power of 4, to the power of 5, it's meaning like 5 times 5 times 5. How many times you do it, okay? You'll get to know it when we come across it. So with strings of division and multiplication, or strings of addition and subtraction, and no brackets, work from left to right, okay? Some examples over here. So we had 6 add 3 times 5 equals 21, not 45. Okay, so you first start with this one. We first start with 3 times 5, okay, which is 15. And then you add the 6, which gives us 21. And some people do 6 and 3, which equals 9, then times it 5, and it gives us 45. That is not correct. The multiplication comes before the addition, so that will give us 21. Next, on 5 squared equals 25, where the 2 is an index power. Okay, so indices. This is the indices. The little 2 there is indices. And in other words, you can say squared, or you can say the power of 2. But usually for 2 and 3 is where you say squared or cubed. So if it was a 3, it would be 5 cubed. If it was a squared, it would say 5 squared. Okay, perfect. Now we've got 12 divided by 4 divided by 2. Okay, so it equals 1.5, not 6. First of all, you would have to do 12 divided by 4, which would give us 3, and 3 divided by 2, which gives us 1.5. Some people do 4 divided by 2, which gives us 2, and then 12 divided by 2, which gives us 6. And that is not entirely correct. Remember, we work from left to right, okay? We work from left to right, okay? Perfect. Now, number 10. This is a more trickier one, okay? A recurring decimal. Usually you need calculators for this, okay? So, a decimal number that has digits that repeat forever, okay? The part that repeats is usually shown by placing a dot above the digit that repeats, or dots over the first and last digit of the repeating pattern. Okay. So, it is also recognized as a recurring symbol. So over here, that little dot is the recurring. Okay, so if I said 1/3 equals 0.333 and the 3 is gone forever, it would be 0. You can just say 0.3 recurring. Okay, 1/7 equals 0.142857. 142,857 equals 0.1 recurring. 42857 recurring. Or you could say over here, 77 over 600 equals 0.12833 equals 0.1283 recurring. You could just say that. Now, do you see how this is really simple, but it can be tricky sometimes, okay? Because you need to know where to place a dot. That is where, okay? So let me explain where to place the dot sometimes. So if I have over here 0.1428571, 142,857. There's 142,857, 142,857. That number will always repeat. So what I would just do is put the 1, put the recurring symbol there, and the 7, put the recurring symbol there. Because I know this specific number will repeat again and again and again. So you just put that dot there. Same as this one. So 1/3 equals 0.33. The 3 will repeat forever, so you just put the 3 recurring, and it will just make it, we know that it will repeat forever. Same as over here. So I've got 77 over 600 equals 0.12833. Just put the 0.1283 because we know the 3's will obviously go forever. Okay, that is pretty simple, and we've just gone through all of this. Now we're going to go to the next page. So this topic is about factors and multiples. Now this is kind of simple and kind of sometimes a bit not very nice, but once you get the hang of it, you'll find it really easy. So let's get to the understanding point. Okay, so our first one is multiple, okay? So it means the result of multiplying a number by an integer. So it's basically the times tables of a number, the multiple, basically a times table of a number. So for example, the first 5 multiples of 7 are 7, 14, 21, 28, 35. It's basically the timetables, all the multiples, okay? That's pretty easy to the first start, yeah? So factor. So a number that divides exactly into another number without a remainder. So it's also useful to write factors in pairs, okay? Now factor pairs, you're going to get to know them when we're on the example bit. This part is a bit tricky. Sometimes you can get a bit muddled up, but once you get to know it and you'll really understand it, you'll find it really easy, okay? But these also do come up in questions quite a lot, okay? So we've got the factors of 18 are 1, 2, 3, 6, 9, 18. The factor pairs of 18 are 1, 18, 2, 9, 3, 6. Now, what do I mean by the factors? The factors of 18. What do I mean by that? So, what it actually means is these are all of the things that go exactly into 18. So, for example, 1 times 18 equals 18, 2 times 9 equals 18, 3 times 6 equals 18, 6 times 3 equals 18, 9 times 2 equals 18, and 18 times 1 equals 18. They exactly go into 18. That's what it means, okay? And the factor pairs. Now, why do people say it's useful to write factors in pairs? Now, the factor pairs of 18 are 1, 18, 2, 9, 3, 6. If you write it, you already know what's going to come next, and you already know what the pairs are, so it's easy for you to list it out. Instead of making a whole long list, you have pairs, and you already know what is what, okay? So 1 times 18 equals 18, 2 times 9 equals 18, 3 times 6 equals 18. You don't need to work it out because it's already been done, okay? That's just more useful to write the factor pairs, okay? So if I were you, I would rather put the factor pairs down, okay? Do the work already, and then it's finished, okay? Perfect. Now, the lowest common multiple, also known as the LCM. Okay, so the LCM is the smallest number that is in the times tables or the multiples of each of the numbers given, okay? So it's the smallest number that can be found in the times table of some of the numbers that have been given. Now, what I mean by the numbers given is, for example, the LCM of 3, 4, and 5. That's the 3 numbers that have been given, and you have to find the LCM of those 3, 4, and 5. So the LCM, you have to find the smallest number that is in the times tables between 3, 4, and 5. And the smallest number, or the LCM, is 60 because it is the smallest number in 3, 4, and 5 times tables, okay? So do we understand LCM? That's perfect. Now, highest common factor, HCF. So HCF is the biggest number that divides exactly into 2 or more numbers, okay? So this time it's the biggest, but wait a second. It's not a multiple, it's a factor. So if we go back up to the factors, it says divide. It says divide over here, okay? But if we go back to the multiple, it's multiplying. So it's a difference, okay? So when you do LCM, you find the multiples. When it's a HCF, you find the biggest that divides, okay? So we go over here, it says the HCF of 6 and 9 is 3 because it's the biggest number that divides into 6 and 9 exactly. So 3 divided by 2 equals 6. 9 divided by 3 equals 9, okay? So let's move on. Okay, prime number. So a prime number is a number with exactly 2 factors. So it's a number that can only be divided by itself and 1. Okay, so the number 1 is not prime as it only has 1 factor, not 2. Okay, prime number is quite a tricky one. People mostly get mistakes on this one. It's really hard to understand, but I assure you, once you get the hang of it, it's easy, okay? So some people take a long time to understand this, but it's not that hard as it looks. So it says the first 10 prime numbers are 2, 3, 5, 7, 11, 13, 17, 19, 23, 29. Okay, so how do we know they're prime numbers? Because you need to know this. A prime number is just a number that can be only divided by itself and 1. Okay, that's literally it, okay? So these all can be divided by themselves and by 1. And have you also noticed they are not in any other timetables, which makes it even easier to understand they are a prime number, okay? They are not in any timetables, okay? Okay, that's easy. Okay, prime factor. So a prime factor is a factor which is a prime number. So, a prime factor is a factor which is a prime number, and the prime factors of 18 are 2 and 3. Now, this one can be tricky sometimes, okay? But once you get the hang of it, of course, you'll know it again. Okay, so it's a factor which is a prime number. So this was pretty easy. It's a factor which is a prime number. And in the previous one, we know what a prime number is, and we know what a factor is. So that's pretty easy, okay? It's basically the two combined. Okay, so thank you for watching part 1. Stay tuned to watch part 2. And please like and subscribe. Thank you. Bye.